NESGameMaker. So last time we were together, we put together a bit of this overworld link object and set things up so that we can go to the overworld and come back from the overworld as a bit of a test. But today we're actually going to build out the link object and make sure that he can actually do things. So let's get cracking. Get us started with, we need to create a bunch of events for our link overworld object. We have the create event and the step event already, but we also need a draw event and a draw GUI event. I think this is actually, we're not going to use the draw GUI. It's just for debugging purposes, but we'll put it there for the time being. It won't hurt anything. And of course, we're going to need our user events 0 and user event 1. So we have here over in our create event, we have this little bit of code here which sets the camera to be targeted to me at this point. And that's kind of ubiquitous. And of course, we also have the methods, and we have the enums for the overworld player and the battle tile type, which will be used later on for determining what enemies we want to spawn. But we're going to need to bring in a bunch of variables and stuff to finish off our object here. So to get us started with, we're going to start with the animation variables. So we have our X position, our Y position would be, these regions are kind of arbitrary, so me putting X and Y in the animation is just arbitrary. Anyway, so this just ensures that when the link object is created, he'll be at wherever in the overworld you have set his location to be. So let's say you have a cave or something over in the overworld. Link enters into this cave here. Then you need to be able to actually enter that cave, and when you exit that cave, you also want to exit at that cave. So when you enter the cave, you would update your current save data with the overworld X and Y position in order to make sure that you bring a link back to the proper position when you return to the overworld. Image speed is equal to 0. Facing direction is dir4.down. State is idle. Manual sprite change is false. Frames of state 0. X scale is equal to 1. Do I even use that? Oh, wait, yeah. I use it when you're going left and right because you just have one single sprite and I'm just flipping it around with the X scale. Animation length, it's how long we want animation to play between cells, and because we're going to be doing a grid-based movement here, and so as part of the grid-based movement, we basically have a system set up that will automatically determine the length of each frame that should be displayed such that every single frame will be displayed evenly in your walk cycle between each grid cell as you move between them. Input buffer length, again, X input buffer, Y input buffer, we'll use these in a little bit. Battle room 2, this basically is going to be used to get us to the battle room whenever we enter into a battle situation. And current title type would be battle tile type.none, because we're currently, it doesn't really matter. We'll update this in the step event every single time, not just have it set to none as a default. This won't be grid bound, animation is grid bound, etc. So we simplify a lot of the movement information. We just have the X input, the last X input, the X motion, Y motion, XL, X from, X2, and Y2, and etc. And of course our collision information. And last but not least, we'll have some spawning stuff, which I'll get into in a little bit, but to get us started with, we'll just have our sprite lookup table. Dir4.right be walk right, up, walk up, left be walk right, but we'll flip it using that X scale variable. And therefore down is walk down. And same thing for these. You get the movement and the rafting states. Though we don't really use the rafting states. So, yeah. I mostly had them there just in case I did feel like doing it, but I didn't. So, anyways, so we got pausing. We got let's see what we got for our step event. We got a bunch of stuff going on here. So we're going to delete this transition system here because we don't need it anymore. We're going to put in the actual transition system at this point. We're going to bring in some input. So we have our X input. If our, well, we have our X input and our Y input. It's the regular right minus left, down minus up. Input buffer for the D-pad. So this setup was so that you could have relatively smooth movement as you move between left and right and up and down and stuff. So that if you press down, so if you're moving to the right, then you press down just as you get to the right, to the position where you would be at the right. This cause if you press it, so if you press down slightly before you reach the actual full right position in your right movement, then it normally would be ignored. But we're going to put in a buffer system so that your down input is considered a couple frames afterwards. That way your motion feels more natural, as opposed to if you try to press it down and yeah. I mean, I could probably have used instead of I don't know, some sort of other system maybe, but this is the system that I used at this time. So X input does not equal 0, then last X input is equal to X input. So that saves if it's a left or right. X input buffer is equal to buffer length. Else if X input buffer timer is greater than or equal to 0, then X input is equal to last X input. So yeah, as I was saying, we save if you press left or right, and then we start the buffer timer. And if the buffer timer is still running, then we just keep updating the X last input. So if you pressed right and then you change your mind and you press left, then it will save that you are pressing left rather than, oh, excuse me, trying to press right. So same thing for the Y input. All right. So we're going to bring in a couple things which are pretty standard here. We have our state execution, same as normal. We have our positional clamping. We're just clamping our X position to the room width minus our sprite width, and a room height minus the sprite height. It's pretty normal. In all reality, you should never actually really, well, I guess you would, because the left side of the screen here, as far as I know, it doesn't have any mountains over there. So yeah, you don't want to be able to go off the left side of the screen there. Timers. So we're going to have an encounter timer and our X input and our Y input buffer timers. So yeah, for our X input and our Y input buffers do not equal -1, then just approach us down to -1 by 1 each frame. So, or you could have just done X minus minus. It's the same deal. You know, I just trying to be over provision it when I was doing it this way, I guess. Maybe. Encounter timer is actually going to be important though as well, because we're going to be using that to spawn mobs while we're in the overworld. So we'll get to that in a bit here. Control M, close all these things up. That gets us the states, so that just leaves encounter checking and spawning mobs and pausing, but I don't know if I'll get around to doing pausing for everything here, so That isn't very nice. So based on my tile, we're going to do some spawning. Let's go back to our create event here, and we're going to set up our variables. So pound region spawning stuff, pound in region, and bring in some variables. So put them in the right place, and don't accidentally copy the link. There we go. So we have a step counter, steps to encounter, 16, encounter timer, sec times 6, current tile type, undefined. So what do these all mean? So while Link is on the overworld, there's a timer that counts down for how long before mobs spawn. And there's also a step counter. So if he moves X amount of steps based on what the current tile type is, then he will spawn a mob, or pack of mobs, I guess I should say. So, like, if you're in the hard zone, if every 4 tiles that you move, you'll spawn mobs. Versus in Hyrule, where the easy zone, you have 16 steps to encounter before you spawn a mob. And the encounter timer is 6 seconds. So every 6 seconds, you'll spawn enemies, regardless of whether or not you're moving or not. Unless you're on the road, in which case both of them are ignored. And that gets kind of annoying at that point. So anyways, come over to our step event. To spawn mobs. Do I want to spawn mobs or encounter check first? Let's bring in the encounter check first, because we'll use that for checking if we are going into a overworld encounter or something. So put this after input. Whoops. The reason why I don't record at night mostly is because I don't want to be yawning all the time during the episode recording. But fortunately, I'm recording at night this time, so you get the yawns. So we're going to use our typical encounter check code here. We have here our instance place. Our instance is equal to instance place, object overworld encounter. If instance does not equal no one, then do stuff. Object overworld encounter, what is that? Well, that's going to be our mobs that we can encounter. We'll build those in just a second here. There we go. So we would have this switch here. So we have the current tile type will be updated based on this stuff right here, which is apparently exactly the same thing as right there. But basically, I'm having a little miniature state system here where we have based on whatever the current tile type is, we will determine whether or not what room we want to go to. As far as it goes, I only ever put in one battle room type, so that's why we only go to one battle room. But if we had more than one battle room, we would go to different battle rooms. So if we're in the grasslands, we would go to the battle room grass. If we're on the forest, we go to battle room forest, etc., etc. As for updating our tile type, again, so we have our collision tiles right here, right? Well, I didn't really do this, but we would have a second layer here, and then we'd give it a oops. So our collision tile layer has this, which has an enum associated with it for tile type dot wall. This says tile type dot platform. This is tile type dot ladder. So I'd have an enum for tile types like tile type forest, tile type. Well, actually, I have the enum right here. battle tile type none, road, West Hyrule grass, West Hyrule forest, etc. And the things I didn't program in would be just having a bunch of tiles that are associated with each one of these battle room types, which would then I just paint over the grass area and say, okay, this is grass tiles. If Link is touching these tiles at the end of his movement cycle, update his current tile type to be grass tiles, and so on and so forth. And that's a way to be able to see. Typically, you would actually just use the actual tile type, except we didn't tile it. We just used the background sprite for everything because that's much easier than tiling it. So it's just how you choose to do it. And in more modern approaches, I would basically use this type because when I'm working on actual tiles, they're more likely to change based on me updating the tile set or something versus this using a collision tile set, which would be more likely to be fixed and not change. So, anyways, we've set up our battle room, which one we want to go to. Then we'd say play the sound effect enter battle room, cue new song, battle music, which as we know from our setup, it crossfades with the overworld music. Then we do a fanciful transition fade to the battle room at about speed 4, which gives you just like a couple frames of fade transition between each room. Very quick, very easy. Why are you yelling at me? Object Overworld Encounter only referenced once. Yes, that's because I haven't actually made the Overworld Encounter yet. So let's make an Overworld Encounter because we're going to need this Overworld Encounter when we spawn our enemies. So let's see here. We want to go to Objects because I'm in the wrong place. And we have enemies, spawners, and let's create a new object spawner. Object underscore overworld underscore encounter. And we're going to give him a cool sprite because cool sprites are cool, right? Let's see. Game objects. No, it's not in there. Link, miscellaneous, North Palace, NPCs. No. Oh, Overworld. There it is. Give you a create event, a step event, and a user event 0, and a user event 1, and outside view. Not outside room. We want outside view 0 because we are using view 0. So this is fairly basic. Just destroy me because once he goes outside of the view, he gets destroyed. That's just how it worked in the game. Come over to the create event, and we're going to try to keep this relatively simple again. We copy basically all the code from linked overworld into here. So he doesn't get a sprite lookup table because, well, he only has a single sprite. Collisions is the collision layer, the X2, the Y2, etc., all the movement stuff. And our animation stuff is probably the most complex part of it. We also have the make sure we have our methods and so on and so forth over here because we need to have an idle and an move state for this thing. Anyway, so Sprite Index is either Overworld Beast or Overworld Slime. So there's two different types, and based on which one you actually encounter, well, there's probably, I can't remember if there's more in the actual game or not, but for our purposes, there'd be just two types. And based on which type of picture it is, it determines the difficulty of the encounter that you hit. So if you hit the slime, then you have the easy encounter. If you have the beast, then you have the hard encounter. So image speed is equal to 0. State is equal to idle. I don't even know really if we use it. Well, the entire purpose of the idle is just to facilitate the grid-based movement. That you don't actually really use it for anything. Frames and state 0. Animation length, again, it's the same length as link. Time to live is 3 seconds. The encounters live for 3 seconds before the despawn. And direction timer is 256. And step event. So once the timer reaches 0, then destroy myself and exit. Stat execution, you just have the event user. You don't have any of the stuff associated with the sprite lookup table because we're not using it. Clamp us to the room and move our time to live timer down and move our direction timer down. Or once we've actually reached 0, then return us back to 256. Let's see. You live for 3 seconds times 60, so we have 60 frames per second. So yeah, technically you should never actually really reach 0. Which might be why this doesn't really work very well. So we'll see. Bring in our states. So for our idle state, acceleration doesn't have any acceleration, no speed fractions, no collisions and movement, because we're just basically using the grid-based movement, which detects if there's a wall, and if there is a wall, it just doesn't move you into it. Or actually, we're not even bothered with that. He can try to move into it. He just won't go anywhere because he's going to hit up these. He's going to get clamped to the room. Okay, so let's come over here to our states. Let's close all the side stuff there. So this is stuff from going back into the move state. So, like I said, the idle state is mostly just to facilitate the move state because he's always moving. But this is just a way to retarget to the next cell that he's going to move into on the grid. And just a reminder here, each one of these grid tiles is a cell. So I target here, and that's, you can see the map coordinates right here, 2431 and 3819, 39, 40, etc. And we just multiply that by the size of our collision tiles, and we can fairly efficiently move around. Alright, so if instance exists, object link overworld, we only want these guys to move around if link exists, because we are trying to move in relationship to link to some extent. So we want to find out how far away link is from us, and in the X and the Y direction. And this is our movement grid, which is to say this is moving to the right, this is moving up, this is moving to the left, this is moving down. And var move 0, 0. So if direction timer is greater than 64, then put some grid positions where if the spawn mobs, they can just wander randomly. So what we got here is the mob will try to move towards the player unless so in the game there's a bit of a sort of a grid thing that goes on with Link. So if a mob spawns and he's in this corner position, this corner position or this corner position, he just wanders randomly around. But if he's in this position or here, then he will path towards the player at that point. So that's what we're doing. So if you're in one of the four corners, wander around randomly. Otherwise, move towards the player. So direction time. Oh, yeah. That's why the direction timer exists also, because there is a portion of the time where no matter where they are, they just move randomly. But if they are, so if you are in the move randomly time, move randomly. Otherwise, then do whatever your grid position tells you to do, which is move towards the player. So if direction timer is greater than 64, then either move randomly if we are in a random area, or if we're in a targetable area, path towards the player based off of the difference between our position and his position. Otherwise, if we're in the move randomly position, then just choose a random direction to move in and move in that direction. And finally, move if tile map, collision tile map. As remember, right here, set up right there, collision tile map. If our tile map position does not equal a tile, a collision tile, so what we're basically doing here is we're doing a check to see if our X cell position plus whatever movement we've determined we want to try from here. Because remember, we're moving based on the grid, which is a single integer position between each place. So 35, 36, 37, 38. So if we're moving right, we just have to add 1 to the X position and 0 to the Y position to be able to move right. That's the power of grid-based movement for you there. Very simple movement. Change state to move. So if we are not going to hit a wall, then change our state to move state. Set our X2 to be move 0, or actually what we want to do is plus equal move 0. And our X cell equals X2. And our Y2 is plus equal move 1, and Y cell equal to Y2. And get us into the movement state at that point. Whew. We're going over a lot here, but luckily the movement system is stupid simple. Just basically what we're doing here is let's start over here. Collisions and movement. If our time is equal to the minimum of 1, or the frames in state divided by the animation length. So this is used for the animation basically. X is equal to the round, the lerp of x from to x2 by underscore time. So what we're doing here is we're taking our X position that we're currently at, our current X tile. So let's say we're at 35 and we're moving to 36. 35 to 36 time, and time is either at least 1 or some fraction of the animation length versus how many frames we've been in the state at this point. So if we're just starting, we're at 0. So that would be at the minimum of 1 or 0. So of course, 0 wins. So we want to move from our current position, which is X position 35 to 36, by 0. So times tile size. So basically, yeah, we get 35 is our return value there. And 35 times tile size would be 16 times 35, whatever that value turns out to be. And that'll tell me where I want to be at that point. animation is equal to image index. You have this little formula here. So we have the array length of index, which is 2 minus 1. So that's 1 times time and round that. So if time is at 0, then we are basically saying we want to use position 0. And once time reaches 0.5 times time, then we'd be getting a value of 1. So we get to position 1 at that point. As this would turn out to be 0.5 when time is 0.5, and rounding up gives us position 1. This is just how we choose what frame in our animation we want to use. So finally, once our time is greater than or equal to 1, so once we have completed an entire animation loop, aka we have reached our destination, then return us back to the idle state and set our x from equal to our current x cell and our x2 equal to whatever. It doesn't really matter because we're going to change the x2 next frame anyways. So yeah, and then execute the idle state again at that point, where we update and try to find our next movement, that point that we're going to move to. So this guy is now done, hopefully. So he's able to move around the overworld. And Link is still not done himself. We also have this battle room we need to go to as well. Let's create the battle room here over in our rooms section. Which one is this? Rooms. Room underscore battle underscore room. And the battle room is going to be our basically default room size, which is to say 768 by 240. Background asset. So give that a name of background underscore titles, whatever you feel like, doesn't really matter. And we're going to bring in this guy here at this point. Except we need you down here at the bottom of the screen now. We need to come here to our background assets. We need to give you a grid size of 8 by 8. All right. And we want to 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. There we go. And we want to take our background here and we need to give it a color. It's that color, 3CB CFC. And that matches the background color here. Why do we drop down this so much? It's because we need it to be the same height. We need the grass level to be the same height as basically every other room in the game. Which is to say, like North Palace, we have it, what is that, 32 pixels high. So we need the battle room, our grass, to be at 32 pixels high. So let's throw in a collision layer. And we are going to give you a brief tile set and that will match up with the rooms of the palace. And then we just add a bunch of instance layers. So we have our menus where we would pop up our level up menu. Instances. Move you to there. Then we have our effects and our enemies. And again, the reason why we have these in this order is because we want menus to appear above everything. Then we have our player right here. Then we have effects, which would be like explosions and stuff. We want explosions to be above the enemies, but behind the player. That way the effects don't interrupt our ability to see the player, so we keep visual continuity. And our enemies are, of course, they're in the very back, so they're behind everything. So again, they don't overlap the player, and that would make it hard to visually understand the field of battle. And let's see if I can find a list of all the instances in the room. Oh yeah, we'll need link side scrolling, because that's his jam. Except not on the enemies layer, we want on the instance layer, and give you an 8x8 snap because that makes everything easier. Put link wherever. Theoretically, you should be at the center of the room, the hood, whatever. And enemies. So we're going to want to, so for the grassland, we just put in a couple of spawners. So we have a bit and bot. Go over here, bit and bot over here. And theoretically, Link should be far enough away from either side that if he goes either way, mobs will spawn for him. And also we want the moblin spawner as well. Just to make it easier to identify. Give it enemies. There we go. I'll just give him that sprite, but it doesn't really matter. That way, moblins will spawn in that room as well. So where are we at? Oh, we're at 36 minutes. Oh, I've been way too long on this. So we're almost done here with building out Link, I guess. But we still need to give him his own events, like his own movement event, etc., etc. So we'll get back to that next time. So thank you, everybody, for joining me, and I'm going to let Past Me take it away with the Patreon names. I'd like to thank my legacy Patreon sponsors who supported me last season during the hiatus. James Burton, JD Lowe, Suli, and Vazia. I'd of course also like to extend my thanks to my current Patreon sponsors. Kenneth Klein, Confusion, Jamal, Fernando, Sir Jez, and lastly, Amy. Thank you, everybody, for supporting the NESGameMaker. You really help it all happen. And remember, good luck with your program.